So in this video, I'm going to be making snake in Pico-8. What you're seeing right now is a little test run I did earlier, and I'm going to be doing it from scratch, explaining everything I'm doing in like this unedited format. And I'm going to be giving myself 20 minutes, so hopefully it's a little bit of a challenge and it's kind of fun. So yeah, okay, so when you want to make a new project in Pico-8, you just hit reboot, unsave changes, yes. And then when you're prompted to this screen, you can just press escape, and that brings you to the code editor here. So we could go ahead and start our timer. That's ticking down. And yeah, okay. So the first things you'll want to do when making a game is just make your three functions init, make your update function. So init gets called when the game starts, update gets called 30 times per second, and draw will get called after every update. And yeah, okay, so if we're making snake, the first thing we'll probably want to do is just draw the snake on the screen. And it'll be nice to represent our snake as like this object kind of thing. And so in Lua, there actually isn't like objects and classes, but you kind of like mimic object-oriented programming with these tables in Lua. So we give our snake like an X and a Y. We could give it a DX and a DY to give it like the direction it's going in. So maybe we'll start just moving to the right like this. And also it's nice to give your objects a way to draw and update themselves. So we could do this, draw. So drawing the snake, everything in snake is like normally on like a low resolution screen. And a Pico-8 by default is like this 128 by 128, which might be kind of big. So what I'll do is I'll split the screen into like these like grid parts, where each part is like 4 by 4. And we could do that by setting this grid size variable like 4. And when we draw, we can make rectangles. So we'll use this rectangle fill function. Rect fill, the first two arguments are the X and the Y of the top left. So that's easy. That'll be the snake X and the snake Y times the grid size actually. And that'll make sure that they line up. Snake.y times grid size. And then for the next two arguments are the X and Y for the bottom right. And we'll get those by very similarly doing this, except we're going to add 1 to the X and Y part before we multiply it. And we're also going to have to subtract 1 so it doesn't carry over 1 into the next little grid square. Perfect. Okay, and then there's an optional fifth argument for rect fill, and that's for the color. So if we go over into the sprite editor, we could see 0, 1, 2, 3. 3 is the number for the color green. And we can go ahead and put 3 here. And that'll make our snake green. And we just have to call this snake.draw in here. So if you haven't used Lua before, you might like do something like this, passing the snake to the draw function so it has access to all. Oh, I just realized I should be doing self here and not snake. And you might want to do something like this, but actually like Lua has this shorthand that makes this a little bit more clean. So this just means that you're automatically passing this into the first argument. So that's a little bit more clean. We'll do that. And let's see if we get a snake. So we do, but notice how we still have like this console here. That's because we're not clearing the screen. So CLS stands for like clear screen, and we could set a color. So by default it's black. It's just this black color, but let's make it 1 so it's not just the default. Cool. Okay. So 16 minutes and we have the snake head drawn here. So now let's try to get it moving. So we're going to want to give our snake an update function, very similar to the draw. And here we're just going to be moving the X and the Y by its direction. So that's pretty simple. Snake.x plus equals snake.dx, snake.y plus equals snake.dy. So if we run this, we should see it move, but it doesn't. Oh, because we have to call it, of course. So same thing as what we did in draw. We just do this in update. And okay, so now we see it moving very fast. We could restart it with Control R here. And we normally snake games are like limited in their FPS so that it's like pretty slow and you can react to things. So the way we'll change this is we could make a variable called like refresh rate, or let's call it update rate actually. Maybe we'll start at 5. And we'll want to keep track of how many frames we've been counting. So we'll call this like ticks. And in update, we could do ticks plus equal 1. So this will happen 30 times per second. We'll be adding a tick. And if our ticks are greater than update rate, which is 5, update, or maybe like greater than or equal to, then we actually update the snake. And so that means that ticks will be greater than 5, and we'll also want to restart ticks to equal 0. So now it should be a little bit slower here. Sweet, okay. And we could adjust that speed whenever we want, so that's really nice. We could also adjust the grid size, which is kind of cool. So if we want the game to be twice as big here, we could do this, and then it's like even more blocky and low res. That's kind of cool. We'll go back to 4 for now, and I like 5. That seemed pretty good. Now, okay, so it's 14 minutes, and so now we'll try getting the snake to move. So, snake, where will we want to do this? So if we do this in snake.update, then it'll only happen whenever we're doing a tick, and maybe you want to input a direction in between these update frames. So how about we just do this inside of update so that it could be seen on every frame here. So if, the way we check for input is if button, and we're going to want to use our arrow keys. And the way we use our arrow keys in here is we could press shift, and then if we wanted the right arrow key, we just do shift R. And that is kind of like a cool little functionality thing Pico-8 has. So if button this, then that means we're pressing right. And then what we do is snake.dx equals 1, snake.dy equals 0. And we also have those 3 other buttons, and we can make else ifs for those. And then 2 more buttons still. Alright, and now we just edit through these. So this will be up. So okay, so the kind of weird thing about Pico-8 is that the Y direction, if we do -1, we're actually going up. That when you increase in Y value, you're actually going down on the screen. Actually, I think that's just like most programming coordinate kind of things. So like it's always in, what would that, coordinate 4? In like middle school we learned that. So like think of everything in programming as like coordinate 4, where when the Y value increases, you're actually going down on the screen. So then we have snake.dx -1 when we're going left. And when you're going down, shift D, you are going 0 and 1, +1. Cool, so now we should be able to move our snake. And yeah, that works good. So I'm pretty happy with that. So we have our snake head. We don't have our snake body yet. The next thing we could do is apples, because that'll be working towards the event that causes the growing of the body. So apples are interesting because we might want more of them than 1. Like in the snake case, we just had 1 snake. And so it's almost like we want to make a class that we can make multiple objects of. And the way I like to do that with Lua is make a function, and maybe we'll call it like make apple. And then we'll do something very similar to snake where we make a table, and at the end of this function we're going to return the new apple we made. And the only things we really need for the apple are an x and a y. And we could pass those arguments, but actually we're never going to want to actually like really set an apple at a specific spot. We're always going to want like apples to be randomly generated at a spot. And the way we'll do that is using the random function. Random generates a random decimal number from 0 to whatever number you put as its argument. So we want a random number from 0 to 128, which is like the resolution of the screen, divided by grid size. And we're going to want to floor this so that we don't have a decimal. And we can do the same exact thing for y, so we get a random x and a random y. And yeah, okay, so we'll want a place to store these apples. So maybe we declare a table of apples. So tables are like very versatile. You could use them as like lists, arrays, objects, but in this case we're just going to use it as a list to hold apples. And we're going to generate our apples on the start of our program with a little for loop here, maybe I equals 1 to 2. So this will just mean it'll happen 2 times, and we'll be making a new, we're going to be adding to the apples list an apple, make apple. Awesome. So that should make apples like that. Also, we're going to want to give apples the ability to draw themselves. So draw function self, and we're going to want to, it's going to be very similar to how the snake draws itself. So we could actually just copy and paste this, and we're still using self, so that's really helpful. The only thing we could change, well, we'll want to change, is this color, and we can make it red. So 3, 4, 5, 6, 7, 8 will be the red. And awesome. Okay, so we are making 2 apples, but if we run it, we won't actually see them yet because we haven't drawn. Oh, we have an error too. So how about we fix that first? So the error is global grid. Oh yeah. So not grid divided by size, but grid underscore size is the name of our variable. And we have another error here. We're adding to the apples array. Oh, it's a add, not new. Yep, okay, so that is good. But now, if you notice, we didn't see our apples yet, and that's just because we have to call the draw for all of them. So the way we do that, we go down to here, for apple in all apples, do apple.draw. And we want to do semicolon so that it gets itself, the same thing as the other one. Awesome. Okay, so now we have these apples, but if we go over them, nothing happens. So yeah, so we'll do that next. So if we touch an apple, we just want that apple to go away and be respawned somewhere else, basically. So we could do that inside of snake update. So here we have our snake X or snake Y. So we'll want to look at all the apples and see if any of them are at the same location as the snake. So very similar for loop here for apple in all apples. Do if the X of the apple equals the X of the snake, and the apple.y equals the snake.y, then that means that our snake is inside an apple, and we could delete from the apples list that apple and add a new apple. So this will just like generate a new apple at a new random spot. So we'll see if this works. Okay, so we have an error. Oh yeah, so this isn't a function. Our function is make apple, I believe. Make apple. Yep, okay, so this should work. So when we touch it, it should go away and spawn a new random one. Yep, perfect. Okay, so we have 7 minutes left. I think we're doing pretty good here. Now we'll want to add to our body whenever we eat an apple. And to do that, we're going to need to know where our snake previously was, because that's where our body will be going. So we're going to add a previous X and previous Y to our snake. Maybe it'll just be like a, well, actually what it initializes to doesn't really matter because it'll be updated on the first frame. And an update in here, if we find out that we have touched an apple, then we want to add a body segment. There is kind of like a weird edge case where if there are 2 apples on top of each other, we could like spawn 2 body segments at the same time. We don't want that. So a way around that is 8 apple equals false. If we happen to see an apple, we set that to true. And I accidentally did something here. What did I do? Where did this end come from? That is strange. Okay, yeah, I messed. Okay, there we go. And so if we ate an apple, then we could add the body part. And this will only be triggered once if we eat like 2 apples in one frame for some reason. And the way we do that is we'll want to add, maybe we have like this property called snake.body, and we add a new body segment with an x, and so every body segment will have an x and a y, and we could set that equal to the previous x and the previous y. So self.prev x and y equals self.prev y. And now we just need to make this thing called snake.body. We could do that like under here. Snake.body is like a list. And that makes sense. Let's just make sure we don't get an error here. Unclose. Oh yes, I just need to close this parenthesis. Expected ends. Okay, so maybe I did mess up an end somewhere. That's strange. We have this update, and that has an end there. That's kind of confusing. I'm not sure. Oh, do we have an extra end? Where's that end coming from? Yeah, I think we just get rid of that. So I think I created an extra end somewhere that, yeah, cool. So right now we're not going to see the body, obviously, because we need to draw the body parts. So the way we're going to draw the body parts, we can do that inside snake draw. And after we draw the head, for part in all self.body, we're just going to draw the part. Which is, we don't even have to edit this rect fill code because this is exactly what we want. Oh, except the part. Part instead of self. So let's see how this works. Okay, so, oh yeah. So it's going at 0, 0 because that's what we initialized it to, and we never updated previous x and previous y. So that's a really easy fix. Before we update the snake x and snake y, we say snake previous x equals snake.x, snake.previous y equals snake.y. And then what we're going to see is we're going to have these body segments that are like going to be frozen behind us. But at least we have those being spawned. So now we just need to make sure that they follow the head, or like the body part that's right in front of it. And the way we do that, we can do that inside of update. Update of the snake, I should say. So we have draw, we have snake.update, and we could do it before we check if we had an apple. After we moved our head, for part in all body, do the part.x equals snake.prev y, part.y equals snake, oh, and this should be self.body, not just body, because body doesn't exist. Previous x and y. Okay, and we're going to want to set a new previous y to where the part was. So we're doing like a little swap here is basically what we're doing. So maybe we could save that part.x original y equals part.y, and then our new previous x and previous y become these originals. Original y. So that should update all the body parts, I believe. And we'll see if this works. Go down here, pick up this. Look at that, yeah. Okay, cool. So we only have 2 minutes. We might not be able to get everything we want, but one thing I would definitely want to do is score. Score is really, really easy because we go down here to draw. Maybe before, it doesn't really, as long as we do this above something. Actually, we probably want the apples to draw above the score just in case that like the apples get drawn near the score. So we'll put the score underneath everything. And the way we do that is print, you give it a message, and what we're going to give it is actually the length of the body. Because if you think about the snake's body, the length of how many body parts it has is actually your score. And the second and third arguments of print tell you where the x and y are going to be of the top left of the message. So we'll give it like a little bit of a margin on the top left. And then we give it a color. Maybe we'll just give it white here. So 3, 4, 5, 6, 7. So it's easy to read. And let's see how that works. So error. Oh yeah, I said score, not a. So what I was saying is we should be doing snake.body. and the size of this body will tell us that. So this is like a hashtag. It's kind of hard to tell, but this hashtag in Lua tells you how many things are inside of a table. So right now it's at 0. You could also use it for like strings, I think, too. 0, 1. Oh, that's cool that 2 apples spawned together. That helped us out. And yeah, okay, so we're about out of time. We have 15 seconds left. So we weren't able to do like losing. If we touch ourselves, we don't lose. If we go out of bounds, we don't lose. But I'll leave that up to like an exercise for you to do. But we did, I'm pretty happy. We got scroll working, we got like the tail working, we got movement working. So yeah, I'm pretty happy with this. And you have some things to add. So go ahead and add. If you go out of bounds, you probably want to lose. If you touch yourself, you lose. And then you could like make some text that pops up like game over. You'll probably want to like freeze the player. And if you press the button, there's actually like a nice little trick to reset the game. If you just call the init function here, it'll actually restart the game because we're setting everything back to like its original values, because we did good to not set any values outside. And then, what's also kind of cool about how we implemented this is our grid size. So we could change the size of this and we could change the speed of it. So if we do 8, it'll be twice as big. So that's kind of cool. Or we could also go really small and do like 1 even, go down like 1. So as if we're just using the whole 128 resolution. And then maybe we do this in conjunction with like a faster rate. We lower this to faster the rate. And yeah, so the way we programmed it gives you a lot of flexibility, so that's kind of cool. All right, thank you.